All right, well, it looks like everyone's here. Let's get started. Today's webinar is called There's a Statistically Significant Probability that You're Doing P-Values Wrong. This is a topic that a large number of Upwave's customers have requested that we address more thoroughly. What does statistical significance and P-values mean, how to use them, how not to use them? And it's a fascinating topic to explore because it actually is a topic of relevance, not just within advertising research or marketing research. It's actually a large societal issue that is being discussed in academia. It's being discussed in newspapers on how to present findings from research. And it's relevant to everyone involved in advertising. Because whether you're a researcher, whether you put together research reports on advertising, or whether you are consumers of those reports, make decisions based on those reports, you are involved with these issues. How you do your job is critically dependent on where you come down on these issues, how you interpret p-values and statistical significance. And as Upwave can say with confidence, the title of this webinar, there is a statistically significant probability that you're doing it wrong. And so how can we do it right? That's what we're going to dive into today. So we run into headlines like these every week that have nothing to do with advertising, but use the exact same metrics that we use in advertising to make claims. New study finds drinking a glass of wine is as good for you as an hour in the gym. The latest scientific research shows eating chocolate causes weight loss. Drinking more coffee can reverse liver damage from booze, study says. So we instinctively are inclined to give credibility to this claim because they're scientific claims, right? Well, that's not what a large number of researchers around the world have been saying in the last several years. In fact, experts around the world have been urging change. So a large number of the most prominent statisticians on the planet put together a statement saying that we should, quote, stop using the term statistical significance altogether. Now, that may come as a surprise to you if you use this term or hear it used all the time, and you assume it's just commonly accepted. To hear that actually many of the most prominent statisticians in the world are urging us to stop using it entirely. You can see articles in many journals like Nature, the American Statistician, raising the alarms about this. It's time to talk about ditching statistical significance. The false positive risk, a proposal concerning what to do about p-values. And this isn't just limited to the halls of academia. This is something, for example, that affects e-commerce research. So the most prominent e-commerce experiment platform, Optimizely, they pretty much removed the use of traditional statistical significance and p-values from their platform in response to what they saw was an alarming use of their platform to make bad decisions on e-commerce sites. The use of their platform that led to a 5-fold increase in error rates and bad optimization decisions. And it's not just in e-commerce, it's also in advertising. So in advertising, we regularly see claims like this. Out of home is 80% better for abandoned cart retargeting. New campaign driving stat sig lift in 2 days. A 300 by 250 placement is leading CTV and brand awareness by 1,000%. And these claims give us pause, but we see that they're statistically significant, that they are based on principles of science and scientific research. And so we're kind of conflicted. We're inclined to give them some credibility at the same time. And it's hard to know what to do. And so that's what we're going to address head on in today's webinar. So let's talk about what are p-values and statistical significance. A p-value is a statistic used to evaluate the validity of the results from a scientific study after it is finished. So this is a critical point to keep in mind. P-values are meant to be evaluated one time in a study. There are rare modifications of how p-values are calculated that allow them to be evaluated throughout a study. That's in fact what Optimizely did. But those modifications of p-values are rare, and we have yet to see them be used anywhere in advertising research. Advertising measurement platforms and researchers always use the traditional calculation of p-values, and that traditional calculation of p-values can only be evaluated one time after the study is finished. So results with a p-value of less than 0.05, people frequently just call it 5%, even though it's technically not a percentage, but 0.05 are generally considered statistically significant. Now, so you might have thought that statistical significance and the p-value are two different metrics. In fact, they are the same metric. There are two views of the same metric. Statistical significance is a threshold of the p-value. So if the p-value is below some threshold, it is identified as being statistically significant. Achieving statistical significance means the finding of lift is not likely due to random chance. That's all. That's all that it means. Now, you may be wondering, where did this 0.05 come from? Well, the 0.05 is a fairly arbitrary line in the sand. There's not some other study out there that shows that 0.05 is any better of a threshold than 0.06 or 0.04. What is important is to use the same threshold across studies. Because if you use the same threshold across all the studies that you are evaluating, and you always only use them one time at the end of the study, then the false positive rate, the number of times that you say that it's statistically significant and it turns out not to be, will be kept steady at 5%. So that's where the 0.05 comes from. Is there's nothing important about that number. What's important is that you use the same p-value all the time, which is why it's important to pick a number. Another point to make here is that achieving statistical significance, what that means is not that the observed lift, let's say the observed lift is 10%. It doesn't mean that that is not due to random chance. It just means that any lift at all, the finding that there was lift, any lift at all, is not likely due to random chance. Now, for those of you in this webinar who do come from more of a statistics background and want more of the technical definition of statistical significance, I can tell it to you tell it to you that statistical significance or a p-value is the probability that a finding of lift that is as great or greater than the observed lift, the probability that we would have that same observed lift or a greater one if in fact there was no lift at all. So that's pretty much the same way of saying, in slightly more user-friendly terms, the finding of lift is not likely due to random chance. So, all right, that was kind of tough. That was some difficult material. Now let's try to bring this back to earth. So what's the problem? With enough data, all results, even small correlations, show a statistically significance. All right, this is otherwise known as p-hacking, a term you may have heard. Even John Oliver devoted an entire show recently just to the topic of p-hacking. And that's because the p-value, and thus statistical significance, is driven by two things. It's driven by how big is the observed lift and how much data do you have. So with enough data, even a small observed lift, one that's likely just random noise due to a small correlation, will show up as statistically significant. Because again, p-values and the statistical significance are driven by both the magnitude of the observed lift and the amount of data, the sample size. Checking for statistical significance multiple times leads to false positives. So we said earlier that statistical significance and p-values can only be evaluated once at the end of a campaign. If you evaluate them multiple times throughout the campaign, then that false positive rate of 5%, it dramatically increases the more you look at statistical significance during a study, during a campaign. And what can actually be concluded from statistical significance is actually not very helpful in advertising measurement. This might be kind of a letdown, but there's good news that we'll get to later in this. So why does this matter for advertising? Well, advertising campaigns operate in a multifaceted and dynamic environment, and so campaign tactics need to be measured and adjusted mid-flight to improve performance. All right, checking stat sig repeatedly during a campaign, though, virtually guarantees false positives, which means it virtually guarantees that you are going to make a lot of mistakes in your optimization. Okay, so this is the problem Optimizely was confronted with. Acting on false positives will decrease your campaign performance. All right, so on people's e-commerce sites, people were using Optimizely and not waiting till the end of a campaign, till the end of a study to see what was the best hero image for a homepage. They were making decisions early before the experiment was over. We do the same thing in advertising every single day. We look at statistical significance results mid-campaign, and we make mid-campaign decisions that are more likely than not mistakes. They're false positives that will decrease campaign performance. Even when used correctly, so waiting till the end of a study, a statistical significance results only means the success of the tactic was not likely due to a random chance. It gives no indication of the performance of that tactic versus other tactics. All right, so this might be feeling like some hard medicine that we're taking here. But it's important because once we know the problem, then we can start solving the problem. And it's not a problem we can sidestep or avoid, because ultimately, when we make decisions based on bad data and bad metrics and bad findings, it hurts campaign performance, and that bad campaign performance ultimately will show up and reflect on our work executing and designing advertising campaigns. So we have to take this bad medicine in order to understand the problem and then solve the problem. And that's what we're going to talk about. So let's go through a specific example. You're running a 3-month direct buy campaign across 2 publishers with the goal of driving brand lift. All right, so pretty simple example. You have 2 mid-campaign reads. After 1 month, publisher A is driving 7% lift, and the lift is statistically significant. Publisher B is driving 2% lift. So you shift budget from publisher B to publisher A. Well, then after 2 months, things look very different. The observed lift for publisher A has dropped to 1%, and it's no longer stat sig, whereas publisher B, they've now doubled their observed lift, and it is statistically significant. Now, it's at this point that you start to cast doubts on the credibility of your measurement platform. Is it calculating statistical significance correctly? Is there a problem? In fact, there is no problem. This is actually the reason why statisticians from around the world have been pleading that we stop using the term statistically significant, because it's so often misinterpreted and used multiple times throughout studies. So in this example, the final campaign results, after the dust is cleared, what we see is that publisher A drove 3% lift and it's statistically significant, and publisher B drove 5% lift. Greater lift, but it's not statistically significant. And that might seem confusing, but that this is all very statistically valid results. So what should have happened is we wait until the end of the campaign to look at these results. We look at them one time at the end of the study, and what we see is that publisher B drove 5% lift, publisher A drove 3% lift. Now, why would publisher A's finding of 3% lift be stat sig, even though it's a smaller observed lift than publisher B? Well, remember, there's two factors that drive a p-value down and make it more likely to be statistically significant. One is the observed lift. Publisher B has a higher observed lift. What's the second one? The amount of data. So in this example, publisher A likely had a lot more data behind it. It was probably, we probably had more budget moved to publisher A throughout the campaign. So we had more data. And so as a result, we have more confidence that the finding that there is any lift at all is not due to random noise, is not due to chance, than we do with publisher B, even though publisher B has a higher observed lift. So what can we not conclude from these post-campaign results? We cannot conclude that running any campaign on publisher A in the future will drive a 3% lift. We cannot conclude that publisher B drove a 5% lift. And we cannot conclude that the relative lift driven by A versus B is significant. But what's the good news? What can we conclude? We can conclude that the finding that publisher A drove lift was not likely due to random chance. All right, that's what statistical significance means. And we can conclude that if we were to run the exact campaign, not any campaign, but the exact same campaign on publisher A again, the result, the observed lift, 3% would be similar. This 3%, it obviously has a margin of error, or error bars, you can visualize it as. And so it will not be 3% exactly, but it'll be similar. It will almost certainly be within those error bars if it's the exact same campaign. All right, so what are takeaways? Be skeptical of mid-campaign results that are identified as stat sig. That is more likely than not to be a false positive. Only use stat sig to validate results at the end of a campaign, as this metric was intended to be used. And finally, use a metric designed for optimization during a campaign. Upwave has such a metric. It's called an outperformance indicator. All right, so like Optimizely, Upwave has solved this problem, and Upwave has solved this problem by coming out with a metric that does not increase the number of false positives as you evaluate it more often during a campaign. So rather than being based on statistical significance, this actually answers the question that's being asked. This answers the question that's being asked mid-campaign, which is, which tactic is most likely to be helping the campaign, lifting the campaign average? And what's the probability that each tactic is helping the campaign? Well, critically, p-values don't answer that question. The probability that a tactic is helping the campaign. these upwave outperformance indicators do. All right. So we have some questions that have come in through Q&A, a couple questions. So I'm going to take them before we wrap up. They're very good questions. The first is, what should I report in mid-campaign reads? So what you should not report is statistical significance, because statistical significance reported in mid-campaign before a study is over is more likely than not to be a false positive. What you should report, you can report observed lift. What we would advise is to always report observed lift with the margin of error. So let's say in the middle of a campaign, we're seeing that the observed lift is 3% plus or minus 2%. So it's somewhere between 1 and 5%. All right, so this kind of a finding will be technically statistically significant. If that margin of error does not include 0, that's the same thing as saying it's statistically significant. But we would advise against, don't say that it's statistically significant, because that's likely due to a false positive. Rather, give the margin of error. And providing the observed lift with the margin of error, in this case 3% plus or minus 2%, with a reference to the fact that as we collect more data, this read will get more precise of the observed lift. It'll be somewhere, we believe, within this margin of error, and those error bars will shrink over time. What's good about that is it only provides as much information as you know, and not more. And it sets the consumers of this research their expectation that there's uncertainty here, and it will get more precise with time. Whereas using the term statistically significant pretty much eliminates the uncertainty. It communicates that there actually is not uncertainty here. And that's what we want to avoid. But what you can also report if you're using Upwave mid-campaign are Upwave optimization metrics. So you can report findings such as publisher A has a 75% probability of helping the campaign, and publisher B has only a 25% probability of helping the campaign, which means a 75% probability that it's hurting the campaign or bringing the campaign average down. These are different than what you get with observed lift or p-values. This is a different metric that answers actually a question that is more relevant to mid-campaign reads, mid-campaign reporting. So Upwave users use Upwave optimization metrics in mid-campaign reporting. And then they also use observed lift with error bars. The next question is, can I at least say mid-campaign stat sig is directional? So this is a good question. We hear this a lot. We see mid-campaign results that are being reported as stat sig, but because it's mid-campaign, or let's say it's stat sig at the lower threshold, such as 0.8, researchers will say it's directional. So this is problematic to flag these mid-campaign results as directional. A mid-campaign stat sig is directional. You can say that, but the reality is we have to recall that most of the time what we call directional is random noise, and it actually points in no direction. So you have to consider the credibility of your measurement when you say that something is directional and that direction keeps changing from report to report. That's the risk of taking mid-campaign stat sig reads and saying it's directional, or taking a stat sig at a very low threshold and saying, well, at least it's directional, is that when the direction keeps changing, it undermines credibility and confidence in your research and measurement. So we would always advise sticking with reporting observed lift with error bars, reporting the optimization metrics that I referred to that are available from Upwave, and set the research consumer's expectations that as more data comes in, these reads will get more precise and we will reevaluate. But statistical significance, we will only provide a read on that at the end of the campaign. But isn't that really what makes the most sense? What we need mid-campaign are metrics that help us increase the probability that the campaign will drive stat sig lift by the end of the campaign. Knowing that the campaign or a particular tactic was quote unquote stat sig mid-campaign actually doesn't get us there. It doesn't help us. And when we act on stat sig metrics mid-campaign, it actually makes it less likely that the campaign will be stat sig at the end. That's the real folly of using stat sig mid-campaign. So we need to use metrics mid-campaign that were designed for mid-study results, mid-study reporting. And if we use those mid-study metrics and act on those mid-study metrics that only report out as much information as we can actually confidently act on, then once we get to the end of the campaign, we have maximized the probability that the campaign will be driving statistically significant lift. So I hope this has been helpful. These were excellent questions, and this was an excellent discussion. If you have more questions, please feel free to reach out to Upwave, to sales or your CSM at Upwave. And we look forward to talking with you at our next webinar.